Geometry Chapter 2, Lesson 8, and I wanted to wrap this lesson up by showing you how we can apply these special triangles to real-world situations so I'm going to look at some word problems and show you how to do that. Now remember, we're studying these triangles and proportions and relationships and all of these things because using these proportions and using these special triangles, we can superimpose these on some real-life examples, and in doing so we can calculate some distances that are otherwise difficult to measure, or indirect measurement, as we talked about before. So I want to show you a couple of examples on how you do that. And one of the things I want you to kind of get into your mind is that in every example that we read, or in any example, whether we're given a diagram or not, we always want to be thinking, how can I fit one of these triangles in this situation? I'm always trying to put a triangle on the situation. And again, sometimes the problem is given to me, where they give me a drawing or a sketch, and so it's already done for us. The more challenging problems are ones where we have to kind of sketch out what's being described. But just remember, we're always trying to incorporate one of these triangles as I'm drawing the figure. Okay, so keep that in mind as we look at a couple of these. So let's look at a couple of the word problems that you'll have. And again, I'm going to help you set these up. I'm not actually going to calculate these for you. I want you to do that. So I'll get you started. Okay, one example here is where we have the four blades of a helicopter meet at right angles. So as you begin reading a word problem where there is no diagram, you'll want to sketch these out yourself. So you have these four blades of a helicopter. So you got one blade and it meets at right angle, two blades, three blades, four blades. So these would be the four blades of a helicopter, and they meet at right angles. Alright? And it says they're all the same length. So I don't know what these lengths are, but if I wanted to put a variable on them now, all of them would be x because all of the lengths are the same. It says the distance between the tips. Now remember, we're trying to incorporate triangles here. The distance between the tips of two adjacent blades. So basically we're talking about the tip of this blade and the tip of this blade. Okay, that distance is 36 feet. So then how long is each blade? And so that's the question. Now this is going to be a 90, and because both of these lengths are the same, that tells me that this is a 45, 45, 90. So I can incorporate what I know about 45, 45, 90s in order to calculate the length of each one of these blades. So again, I'm not a very good artist there, but anyways, again, so we are able to sketch the diagram, and in doing so incorporate a 45, 45, 90 triangle in this problem. Let's take a look at another one. Let me get rid of all of that, move that over here. Let's see what else I got here. Okay, now here's one where they've kind of given it to us, but we should read it so we kind of know what it looks like for it to be sketched out. So if the problem is given to us where it's not a sketch, we can do that ourselves. An escalator lifts people to the second floor that's 25 feet above the first floor. So here's the first floor, here's the second floor, that's going to be 25 feet. The escalator rises at a 30-degree angle, so my 30-degree angle is here. How far does a person travel from the bottom to the top? So they're asking how far is it to travel from here to here. So again, you can see pretty easily this is a 30, 60, 90. The length that they want me to figure out is this, okay, and that is my hypotenuse. And this leg is across from the 30, so this is my shorter, so I can use that relationship in a 30, 60, 90 to calculate that distance. Okay, this example is a little bit more challenging. It says after heavy winds damaged a farmhouse, the workers placed a 6-meter brace against its side at a 45-degree angle. So they've already sketched this for us, so all I have to do is kind of, as I'm reading it, get an idea of what they're talking about. So this vertical side here would represent the height, the barn, the side of the barn. This is the brace, and then it's at a 45-degree angle. So you can see you have a 45, 45, 90 triangle here. And then they place a longer brace, and that makes a 30-degree angle with the side. So this is 30, so this length here is a longer brace, all right? how long is the longer brace? They're asking me for the length of this. Now let me kind of divide this out. You have this bigger triangle, which if we took it out here like this is my 30, and this is 60 and 90, and this is my x. That's the bigger triangle. And then I have this 45, 45 that sits inside of that, where I know that 6 is x. I mean 6 is the length of this. Now what I need to do is determine this length, but the problem is I don't know either side in my 30, 60, 90. But I notice that the 45, 45, 90 and this side of my 30, 60, 90 are actually the same piece. So I can use my 45, 45, 90 relationship to figure out what this is. And then once I have that, that's going to come over here, and then I would have a side where I could use that to calculate the length of this here. So you're going to use one triangle to figure out the length in another because they share a side, and then you can use that to calculate what you want. So that's how you would do or letter A there. To do letter B, it says how much higher on the house does the longer brace reach than the shorter brace. So the longer brace reaches all the way up here, the shorter brace reaches here, and so what they want to know is how much higher. So we want to know what is this length right here. Now that length from here to here is not part of my 45, 45, 90, and it's not part of my 30, 60, 90 either. I mean, it's not just part of the 45 or just part of the 30. It actually is just this upper part of my 30, 60, 90. So how far is this from here to here? Well, if we think about this, I can figure out the length of this using my 30, 60, 90. So let's call that x. I can also figure out this using my 45, 45, 90. And so what we have here actually is the segment addition postulate. If I call this length A and I labeled this as Y because that's part of my 45, 45, then segment addition postulate says that if I take Y and I add it to A, that's going to give me my entire length, which is this whole side of the 30, 60, 90. So that's going to be x. Now that's not what I want to know. I want to know what A is. Well, I can take this equation and solve it for A, meaning I can subtract y from both sides. So this distance, which they're asking me to calculate, is actually the length of x, which is this whole side of the 30, 60, 90, minus this length of y, which is this side of the 45, 45, 90. So I can use the length of one, subtract it from the length of the other to determine the length that they want me to figure out. Okay, so sometimes we're not interested in just a side of a triangle, but we have to use that along with other things that we've learned in order to problem solve, in order to calculate a smaller part of a whole side. And this is a very common type of problem that you're going to run into quite a bit in advanced algebra, even in pre-calculus. We've been doing a lot of this, where I need to figure out the length of this, which is only part of the side of a triangle. But because I have another triangle inside, and this side I can calculate using trigonometry, or in this case the special right triangle, and this side I can figure out using the special right triangle, I can subtract those two and figure out the missing piece. Okay, so hopefully that was helpful to you setting up some of these problems, and good luck, I was going to say, but I was just going to say, what do I want to say? I don't know what I want to say. I want to end the video, but I don't know how to end it. Let's just say that's the end of the video. That's the end of lesson 8.2. Hope that was helpful for you, and we'll move into trigonometry in the next lesson.